Dear students, this is the last point of this topic, that is photometric titration. So now see here what is the photometric titration. A photometric titration involves the measurement of the absorbance values. So in this case, in this titration, we are going to measure the absorbance value when a sample solution is titrated against a suitable titrant. So in the burette we are going to use a suitable titrant, and in the beaker we are using a sample solution. So the normal titration, so we are taking a sample in the conical flask and we are titrating the sample, we are titrating that sample with the solution which is taken in the burette by use of indicator. So after certain addition of titrant, we come to the end point, that is change in color. So that change in color point gives us the end point of the titration. So similar concept is there, but in this case we are using an instrument which measures the absorbance of radiation while carrying the titration of sample with the titrant. The absorbance value of the solution varies with the concentration of the absorbing species present in the solution. If the concentration changes, then the absorbance of the solution also changes. The absorbance values are measured during the course of titration. So during the titration, we are continuously calculating the change in absorbance values for the sample. Titration can be represented as, so now see here, the reactant is titrated with titrant and it gives us product. So in the conical flask, reactant is there as a sample solution, and the titrant means the solution which is taken into the burette. So both are get reacted with each other and we are getting a product. The end point can be determined by plotting a graph of absorbance versus volume of titrant added. So we are plotting a graph of absorbance versus a volume of titrant. So what is the initial absorbance and the change in volume of titrant by adding, suppose we are adding initially 1 ml of titrant, then 2 ml, then 3 ml, 4 ml, 5 ml, like that, and there is a change in the value of absorbance value. So at the y-axis absorbance is there and the x-axis the volume of titrant added is there. So by use of this graph we can easily determine the end point of titration. The solvent used should not, so the condition is that the solvent which are using should not absorb any light during the course of titration, because if the solvent absorbs the light radiation, then there is change in the readings for the concentration terms. The photometric titrations are restored to when the endpoint is not sharp enough to be detected visually. So why we are using a photometric titration and when we are using it? When a normal titration, in normal titration, if we are not visualizing the change in color or for the colorless solution, then we are using this photometric titration to restore the end point for the compounds where there is no sharp end point. The technique can be used for the titration of highly colored solutions where visual indicators cannot be used. So when the solution is colorless, then we cannot when the solution is colored, we cannot use normal titration, we use a photometric titration phenomena. Now see here the instrumentation part. So here now see this figure, photometric titration cell. So in that cell at the top micro stirrer is there, on the right hand side of the top micro burette is there. In that titration cell reactant solution is there and two windows are there. So this is the window. If you see this window at the front side and at this rear side. So what is the use of that window? We will see here explanation. The photometric titrations are carried out using a cylindrical titration cell which can be inserted in the path of light in a spectrophotometer. So this titration cell is kept in the spectrophotometer between the path of incident light and the receiver, that is detector. The cell has, now see here, two circular windows. So the cell has two circular windows. So the circular windows for what? Now see here, two circular windows through which the incident light enters the solution and the transmitted light passes out into the photocell. So this is for the incident light and this is the transmitted light. So these two windows are used when the photo, that is this titration cell, which is kept in the spectrophotometer. So barring these two windows, the whole cell is covered with a black paper to prevent the entry of any external light into the solution. So to prevent the entry of other light into this titration cell, the whole cell is packed with the black paper. Along with these windows, the cell has two openings for the tip of microburette. Now see here, for the addition of solution, for the addition of solution from the burette, it has a small entry at the upper top of the right and a small entry at the upper left hand side for the stirrer. The reactant solution is first taken in the cell. Now we are taking the reactant solution. The cell is kept in the path of light. The absorbance values are determined after successive installment of the titrant have been added. So what we do now here, so in the titration cell we are taken the reactant solution and with certain time interval we are adding the solution from the titrant into the titration cell, and with the stirrer we are stirring the solution of this sample and the solution which is from the burette. And now the change in absorbance values is determined by use of this spectrophotometer. So this is what the total instrumentation part is there. So there are four types of spectrophotometric titration curves are possible. Now see the first possibility. If suppose the reactant is the absorber of light only, then the titration curve is different. The second type, if titrant, that is the burette solution, if the titrant is absorbing the light, then also the curve is different. The third is, if suppose the product which is forming during the reaction, it absorbs the light radiation only, then the titration curve is also different. And the last one, if both the reactant and titrant both absorb the light but to different extent, then in that case also there are different photometric titration curves are possible. Now see the first one. If you come to know the graph here, now see this graph small a at the left hand side of this here, this graph is there. So this graph, volume of titrant is plotted against the A, means absorbance in the y-axis. If you see this graph, initially the absorbance value is more here, and one after that the absorbance goes on decreases, and after certain volume of titrant added, it becomes a steady line. So now see here, why the graph is like this. We will explain here. Now see this explanation, small a. So what is the first type? The first type is if the reactant only absorbs the light radiation. The reactant is the absorber while the titrant and product do not absorb the light. The absorbance decreases. Now see this graph A, the absorbance goes on decreases during the titration, and after certain volume of titrant added, it remains constant. So that sudden change in the constant, that is change in the absorbance values, is nothing but the end point for that titration. So if you come to know this example here, the titration of para-toluidine in butanol solvent with the SClO4, that is perchloric acid. If you titrate these two solutions in the photometric titration cell, we come to this first graph. Now see the second graph. Initially the absorbance value is steady, straight line, and there is again sudden change in the absorbance values. That absorbance goes on, increases. The second type is of if the titrant is the absorber of light. If the titrant, that is the buried solution, if absorbs the light radiation. Now see the B here, explanation. The titrant is the absorber while the reactant and product do not absorb at all. Now here, initially the absorbance remains constant but increases once the endpoint is reached due to the accumulation of excessive titrant in the reacting solution. So initially, suppose 1 ml of reactant is added into the titration cell, then some amount of compound is formed, but we know that the reactant and product do not absorb the light radiation. Initially the absorbance is steady. After certain time interval, after certain addition of volume of titrant, there is sudden increase in the absorbance value. So that sudden increase in absorbance value, that point of change in absorbance is nothing but the end point. Now the next is third graph. If you see here, initially the graph that is the line starts from the center, that is center of crossing of y and x axis, origin of graph. Then after certain volume of titrant added, it becomes steady. So the third one type is if product absorbs the light radiation. So from the burette we are adding some amount of titrant solution into the titration cell, then some amount of that compound is converted into the product. That is, product is goes on starting, that is product is forming steadily. So initially there is a curve is there, increase in the absorbance value. Now see the third C explanation, C graph explanation. The product is the absorber while the reactant and titrant do not absorb at all. The absorbance increases steadily as the titration proceeds but remains constant once the endpoint is reached, because after the endpoint there is no any formation of the titrant. Now see the last graph. It is like a U-shaped graph is there. So the fourth graph is that if both reactant and titrant, if both are absorbing the light radiation to the different extent, then we come to have this graph like U. Now see this D graph. Both the reactant and titrant absorb due to different extent. In this case, a colored reactant is converted into a colorless product by a colored titrant. So there is colored reactant is there, colored titrant is there, and when both are get reacted, and we are getting a colorless product. So this is what we are getting the graph. So the photometric titrations are used for the estimation of metals in the mixture. So the copper and bismuth can be estimated in a mixture by photometric titration against EDTA. So this question will be asked in the exam for the MCQ. For the estimation of copper and bismuth mixture in a photometric titration, which titrant is used? So the EDTA titrant is used in the photometric titration of copper and bismuth. The last one is, that is advantage and limitation of this photometric titration. What are the advantage and what are the limitations? Now see here the first advantage here. Photometric titrations are restored to when the endpoint is not sharp enough to be detected usually. That is, when normal titration in titration curve, if the endpoint is not sharp, then in that condition we are using photometric titration. The technique can be used for the titration of colored solutions where visual indicators cannot be used. So in normal titration we are using a visual indicator, but in case of this photometric titration, it is used for the titration of colored solution, which does not need a visible indicators. The second advantage is photometric titrations can be carried out in the case of dilute solutions in the concentration range of 10 raised to minus 6 to 10 raised to minus 2 molar. So if more the dilution is there, then we cannot determine the endpoint of titration. But for the photometric titration, if the concentration is in between 10 raised to minus 6 to 10 raised to minus 2 molar, then for such solutions also we can use a photometric titration. Now see the limitation. Photometric titrations cannot be carried out if there is a change in the molecular condition of the absorbing species in solution. That is, if there is an association or dissociation of compound takes place in the solution, in that case we cannot use a photometric titration. The second limitation, photometric titrations cannot be carried out at high concentrations. Means the Lambert-Beer's equation is strictly applicable to dilute solutions. Therefore, we cannot use a highly concentrated solution for the photometric titration. The third limitation is photometric titrations require the use of strictly monochromatic beams which should not be absorbed by a solvent. Hence, spectrophotometers are used here. So these are the advantages and limitations of photometric titrations. The last is the limitation of UV visible spectroscopy. UV and visible light has high energy content, which in certain cases may decompose the organic compounds. We know that UV and visible radiations are high energy radiations, and when we are using this UV visible spectroscopy, the compound may undergo decomposition. So this is the limitation. So in that case, the UV spectrum will give the structure of fragments of the molecule and not that of whole molecule. Hence, UV spectroscopy is not as useful as IR spectroscopy for the structure determination of organic compounds because of the presence of high energy radiations, the compound is get decomposed or get broken. So this is what the whole chapter we have studied, instrumental methods. So from the beginning we have started this chapter with relation between the analyte stimulus and measurement of change in the observable property. We have seen the block diagram of analytical instrument. We also see the type of analytical instruments like optical properties, that is spectrophotometry is there, polarimetry is there, electrochemical properties in that, potentiometer, conductometer and voltammeter. In voltammeter, that is polarography and amperometry, there is 2 points we have seen. We also see the change in thermal properties. If you change, that is the change in thermal properties is also used as a identification property of the compound. So the spectrophotometry, we have seen the single and double beam spectrophotometer, what is Lambert's-Beer's law, and what is single and double beam colorimeter is there. And finally, in the last, we have seen the application of UV visible spectroscopy for the identification of organic compounds, for the identification of cis and trans isomers. And lastly, in today's lecture, we have seen the photometric titrations, its instrumentation and different curves. So this is what the whole topic. In the exam, the whole exam is on MCQ, and in that you have 40 MCQs are there, for each having 1 mark, and this exam will be totally on 3 units. So we have completed first and second unit from the paper 3rd of SY semester 3rd. Thank you.